Hello class, today we are exploring the mechanics of daily life by looking at something you do every single day, which is climbing a staircase. First, we will learn exactly how to calculate the work you do and the gravitational potential energy your body gains as you climb upward against gravity. Then, we will compare two students climbing the same stairs at different speeds to see how timing impacts the power they generate. Before we start climbing any stairs, let's break down the basic physics in principle behind it all. Today, we are defining three core concepts: work, energy, and power. First up is work. In physics, work is done whenever a force moves an object through a distance, because we are lifting our own body weight upwards against gravity. Our work formula is written as W equals to mgh. M equals to mass, G equals to gravity, and H equals to height. Next, we have energy, specifically potential energy. This is the energy gained by an object when it is raised to a higher position. Notice how the formula is exactly the same. That's because the work you put in directly converts into potential energy, which is PE equals to mgh. Finally, we have power. Power is simply the rate at which work is done, or how fast that energy is used. We calculate this by taking our total work and dividing it by time. So our formula is P equals to work divided by time.
Azizul, wake up. It's time for class.
I'm late!
Now we are going to calculate the total height of vertical stairs. The formula to calculate is number of stairs multiplied by height per stair. And in this situation we know number of stairs equals 30 and height per stair equals 0.15. After multiplying it, we got the result to be 4.5 meters. Now for step 2, calculating the work done and the potential energy. We are going to look at two individuals, Amma and Azizul, climbing the exact same 4.5 meter staircase we just measured. Let's start with Amma. To find the work done, we use the formula work equals mass times gravity times height. Amma has a mass of 45 kilograms. We multiply that by 9.81, which is the standard acceleration due to gravity, and then multiply that by our height of 4.5 meters. That gives us a total of 19.86.53 joules. Because the work done climbing up against gravity converts directly into stored energy, his potential energy at the top of the stairs is exactly the same, 19.86.53. Now, if we look at Azizul on the right, you will notice his calculations are identical. This shows us that if Azizul also has a mass of 45 kilograms and climbs the exact same height, the physical work required and the potential energy gain are exactly the same as Amma.
Next, we calculate the power generated by each student while climbing the stairs. The formula used is power equal work divided by time. For Amar, the work done is 1986.53 joules and he takes 10 seconds to reach the top. Therefore, P equal to 1986.53 divided by 10 and we will get 198.65 watts. For Azizul, the work done is the same, which is 1986.53 joules. However, he only takes 5 seconds. So, P equal to 1986.53 divided by 5 and we will get 397.31 watt. This shows that although both students perform the same amount of work, Azizul produced a much higher power because he completes the task in a shorter amount of time.
First, we are going to find the velocity taken by Amar and Azizul. Before that, we need to find the displacement taken by them by using theorem of Pythagoras. Assume the stair is a right angle triangle since they use the same length and height of staircase. So, length for the stair A is 9.6 meter, which is come from 0.32 meters, which is length for the staircase times the 30 staircase, and the height is 4.5 that come from 0.15 centimeter staircase times 30 staircase. After that, we plug into the formula and we get 10.6 meter for the displacement. After finding the displacements, now we can calculate the velocity for each student. First, we are going to calculate Amar's velocity. To find velocity, we are going to use V equals to S, which is displacement, divided by time taken, which is T. So, Amar takes around 10 seconds to climb the stairs, and we are going to divide 10.6 by 10 seconds taken by Amar, and we are going to get 1.06 meter per second. Next, we are move on to Azizul's velocity, which is he takes around 5 seconds to climb the stairs, and we are get 2.12 meter per second. So Azizul climb quicker, and that's why Azizul more faster than Amar to climb the stair.
For the last slide, let's compare the result of both students. As we can see, the work done is the same, which is 1986.53 joules. This is because both students have the same body mass and climb the same vertical height. Similarly, the gravitational potential energy gain is also the same, which is 1986.53 joules. However, there is a significant difference in power and speed. Amar climbs the stair at a speed of 1.06 meters per second and produce 198.65 watts of power. In contrast, Azizul climbs at 2.12 meters per second and produce 397.30 watt, which is about twice as much power. Therefore, we can conclude that climbing the stair faster does not increase the work done or the gravitational potential energy gain. Instead, it increases the power required because the same amount of work is complete in a shorter time. In other words, climbing faster does not require more mechanical energy, but it requires a higher rate of using that energy, which is known as power.